Hello, my name is Samantha and this video is for the class General Chemistry 2 at Doane University. The assignment that I'll be completing in this video is the Interactive Advanced Concept Presentation number 2. What I will be demonstrating in this video is how to make an iodine clock reaction and explaining why it occurs. The materials that I'll be using are a teaspoon, a plate, 3 of these cups, some 10% iodine solution, distilled water, a little ceramic bowl, 3% hydrogen peroxide, cornstarch, vitamin C tablets, and coffee filters. In this experiment, I'll be making 2 separate solutions that will be labeled A and B. For the solution A, the materials that I'll be using are 2 of these 1000 milligram vitamin C tablets that I will crush up off camera, and then also a couple coffee filters and some distilled water, as well as 13 milliliters of this 10% iodine solution. So first I'm going to off camera crush 2 of these pills up and then put them into 60 milliliters of distilled water. Okay, so I put the 2 crushed up vitamin C pills into 60 milliliters of distilled water in here, and this is what it looks like right now. Now I'm going to put this solution into this cup with a funnel and 2 coffee filters, and I'm going to let it strain. It's straining down there, and then I will come back once it is all strained. Okay, so I filtered the vitamin C solution. It's more clear now, as you can see. And then I have 13 milliliters of the 10% iodine solution over here. I'm going to add this to this. And then, as you can see, as I'm pouring it in, it turned clear from that brown color. And this is because the iodine, when mixed with vitamin C, is converted to iodide, which is colorless. Now I'm going to add about 400 milliliters of distilled water to this, and that will be our finished solution A, and I'm going to do that off camera. Okay, now I'm going to start making solution B, which consists of hydrogen peroxide, which is over here, hydrogen peroxide here, and then 350 milliliters of distilled water, and then some cornstarch. So first I'm going to take a little bit of this cornstarch here, kind of estimate my amount of cornstarch, probably about like that much. Yeah, about like that much. I'm gonna put it into the distilled water and just mix it in. I'm going to close this cap here, and then I'm going to mix this. And then off camera, I'm going to microwave this solution to make it clear and then filter it through coffee filters to get any of the additional cornstarch chunks out. And then I'll be adding 150 milliliters of hydrogen peroxide to this solution, and that will complete our solution. So right now, before I microwave this and filter it, I'm going to add the 150 milliliters of hydrogen peroxide to this little measuring cup here. Okay, here's the 150. And then now, and that was of hydrogen peroxide. And I'm gonna mix this into the filtered and microwaved cornstarch in water solution. And that will be our completed solution B. I will do that off camera, and then I'll be right back. Okay, so off camera I put the hydrogen peroxide in the filtered solution B, and that also microwaved it as well, which is in here. So I put 150 milliliters of solution A in this cup, and then 150 in this cup of solution B. Now we're gonna mix them together and see what happens. Okay, so this could take a little while, so I'm going to describe to you what should happen and why while you watch the solution. So after a while, we should see a color change occur, which is the premise behind an iodine clock reaction, is putting two clear solutions together and then mixing together and creating a colored result. If I did it correctly, the color should change. If it does, then what you'll be seeing is when solution A and B are mixed together, the two reactions occur. The two reactions that are occurring happen at the same time and push each other back and forth. The hydrogen peroxide wants to oxidize the I- back to colored I2, but the absorbic acid wants to reduce the I2 back to I-. Eventually, the vitamin C is consumed because of the excess of hydrogen peroxide, so the I2 starts to accumulate again. I2 then complexes with I- before a triiodide complex occurs, and this complexes with starch. And this leaves the solution that blue color of triiodide and starch. The concentration and the temperature of the reactants have effect on how long the reaction takes to happen. So if you have a warmer solution, it would happen faster. If you have a colder solution, it happens slower. Or if it's more concentrated, it would happen faster versus less concentrated. I am going to come back when it starts to change colors, and then I'll show you. Okay, so as you can see, the solution's getting darker as I stir it. It's getting kind of like looks kind of weird on camera, but it's getting kind of like a bluish, purpley color. Which it looks more blue in person than on camera. On camera, it kind of looks more like purpley brown, but in person, it looks more bluish. But overall, you can tell that it did change, and this experiment was successful overall. And it's progressively getting darker, as you can see. You can barely see the spoon anymore, as the hydrogen peroxide eats through the vitamin C and the iodide comes back. So overall, we believe this experiment was successful, and I believe that I explained everything correctly and why an iodine clock reaction occurs and how it occurs. I hope you enjoyed my experiment. Thank you so much. Bye.